Am I audible? Right, awesome. Nice to meet you all. This is actually the 7th time here at Bangalore. And every time that I visit here, it's amazing. Like the people, the food, it's awesome. So happy to be here and nice to meet you all. So yes, I do some of these conferences and I come up and I do these speaking sessions. But at the core, I'm actually a developer. You know, my natural habitat is actually the keyboard, me, and the computer. So I actually spent the last 20 years building enterprise software, out of which I would say the last 10 years, I actually spent building software on AWS. And so far, the partnership with AWS has been awesome. From awesome APIs, documentation, support, I have only great things to say about AWS. And then on top of that, if you actually build on AWS, they actually take care of some of the most challenging problems. Things like scalability, availability, performance, all of those things are actually very, very challenging problems that I know firsthand that is actually very hard to solve. But if you actually use these services, AWS actually offers that out of the box. The other thing to know is about the rich ecosystem. They have hundreds and hundreds of services out there. So if you actually bring your data, let's say in S3 or things like DynamoDB, you can integrate it with countless services. You know, you can actually query using things like AWS Athena. You can actually hook it up with Bedrock. But there are basically countless number of services that you can leverage once you bring the data into AWS. Now, with all that, it will be actually silly for you not to consider some of these AWS native services when you're building something in the cloud. That being, you know, AI applications, cloud native applications, whatever you do in AWS, you know, using the services is actually something that you should seriously consider, both S3 and DynamoDB. And while all that's happening, there's some of the things that is also that you have to do as a user. So when it comes to data protection, it is a shared responsibility model. Yes, AWS will take care of all the infrastructure. They'll make sure that the servers are running. They'll make sure that there's power. Then they'll make sure that all of things is up and running. However, at the same time, it is your job to actually, let's say, create a second copy. It is also your job to actually apply the security primitives. AWS does provide you all of these security primitives, like IAM roles and policies, but you as a user, you have to apply them, just like you have to create those second copies, right? And then let's face this, accidental deletions happens to all of us. So when it comes to, let's say, a delete API, just to take an example, if given a delete API from an AWS context, they have no way for them to know whether that delete API was intentional, accidental, was an attack, right? A delete API is a delete API, and that data will be deleted. And if you actually care about the data, it is your job to actually create that second copy. Now that we talked about the need to actually create backups and secure your data, let's talk about some of the key considerations that you have to think about when it's actually going and protecting your data. The first one is scalability. If you're using services like S3 and DynamoDB, the scalability is real. I talk to a lot of customers, and it is pretty common for me to actually encounter customers with buckets that contains 10, 20, 30, sometimes 80 billions of objects in a single bucket. And these buckets are actually creating 4, 5, 6 millions of objects every single hour. And if your backup or data protection service cannot keep up with that scale, then it starts becoming the bottleneck. And what happens at the end of the day, you're going to start missing your IPO requirement to your business. And you don't want that. So whatever your backup or data protection service, it has to keep up with the scale because these data sources are super scalable. The next thing is flexibility. It's not something that is actually talked very often, but I think, in my opinion, it's some of the things that it is very important. Because you have data of different types. You have data that it is super important, that you have to create a second copy. Not only that, if something goes bad, you want it to bring it back ASAP. You will have type of data that, yes, you would like to have a second copy, but maybe you have the luxury to wait a little bit before bringing it back. You have data that maybe you don't need a second copy, and all you need to do is actually manage some of the local versions, and that's good enough. And of course, you also have data that maybe you don't care backing it up, right? And then the other thing to note, the other dimensions to actually think about when it comes to flexibility, is that the layout, how the data is laid out in these S3 buckets or in these DynamoDB tables, are dictated by the primary application. If you think about it, the primary application is dictating how the data is written into these data sources. And that layout sometimes might actually be aligned with the backup strategy, but sometimes it is not. But when it is not, it is the backup software that has to adapt with that, not the other way around. I actually spent quite a bit of time with the developers talking with them, and very often they tell me, hey, I have this one bucket where I put all my important stuff, and I have this other bucket that I put the rest. It's not that easy. When we double click and I start looking at it, it's never the case. They have prefix inside. Within the same bucket, it's a mixture of different data that you have, and then the data protection service has to be flexible to work with that layout. And then the last one, not going to spend too much time on it, TCO, cost optimization, is pretty much top of mind with every single data customer that I talk to, TCO. And in reality, the TCO aspect of it is also quite related with the flexibility, because honestly, if it is something that you care a lot, then you back it up, let's say, on a standard tier. If you have data that you can actually afford to wait a little bit, you use the archive tier. Not only that, if you have prefixes within a bucket that doesn't need protection, then don't back it up. So flexibility is one way to achieve lower TCOs. All right, so I'm going to switch gears a little bit, and I'm going to talk a little bit about Clumio. Just give you a little bit of a genesis and how it all got started. So Clumio was founded about 7 years ago now, maybe 8 now, but 7 years ago. And we started with the goal of creating a cloud-native backup service to back up all of the cloud-native data sources in the public cloud. Back 7 years ago, and it's still true today, AWS is the biggest cloud provider. So Clumio was natively built with all of the AWS technologies to protect data sources, native data sources within AWS, just like S3, DynamoDB, RDS, EBS, and all of those data services that we protect today. So, like I said, I'm an engineer, and this is an AWS conference, so we're going to geek out a little bit and just going to talk about the architecture. And then from there, we'll go to the lower levels. On the left-hand side, this is the customer's account. This is your account. And these are the data sources that you're trying to protect. The way that you onboard Clumio is through installing a CloudFormation template or a Terraform. This is something that we share with you. And all you have to do is to actually go ahead and install the CloudFormation template in your account. And then what that does is that it will actually go ahead and create a single IAM role in your environment. From the very beginning, Clumio, we started with the mode of creating no footprint in the customer's account. So as you can see, there's no compute, there's nothing that runs in your environment, and then the only thing that you have is just a single IAM role. And that also means that that's the only thing that you have to manage, and there's nothing else to manage on your environment. While that happens, on the right-hand side, in this case, we actually go ahead and create an AWS account. This is an AWS account that is dedicated for you, just for that one customer. It is a single tenant account. So if you have a customer A, we create an account dedicated for that customer A. And if there's a customer B, it will be a different account for that customer B. Think of this being your bunker account with all the security primitives to actually protect your data. So all the data is stored and processed in those dedicated accounts, and these accounts are now commingled. So basically, A and B, they're completely isolated from each other. We're a cloud-native architecture. Everything that we do is pretty much serverless. There's nothing there. There's not a single, server that is running, EC2 that is running, but everything that we do is through Lambda functions, and if there's a backups happening, yes, We'll kickstart hundreds of Lambda functions to get that done very quickly. But if there's nothing to do, then at the same time, there's nothing running there other than just data. All the data gets stored in S3 buckets. And we actually natively integrate with a bunch of AWS services, like I said earlier. We heavily use things like Athena. We also integrate with the S3 access points. And it is a cloud-native architecture if you actually look at it. Now, the right-hand side, it may actually look a little complicated, but the good news for you is that this is all delivered as a service. It is not something that you manage. It is not something that you touched. It is basically delivered 100% as a service. And like I said earlier, the only thing that you manage is that IAM role in your account. That's all you need. That's all you see and you touch. There's nothing else for you to manage. And it is fully air-gapped, to the point that if the entire account on the left-hand side were to be compromised at the root level, there's nothing that could actually delete or compromise your backup data. It is actually housed in that bunker account. Next, let's just go ahead and, we talked about a lot about S3, so let's talk about, some of the key features when it comes to S3 backups in Clumio. First of all is scale and performance. Like I said, it is very, very important because S3 scales very, very high, and I know that. We have customers today with about 70 billion of objects protected, and these are not hypothetical numbers. These are actual numbers from real customers that we have today, that they are protecting 70 billion, a single bucket with 70 billion of objects. And in terms of scale, we are actually the industry leader. There's no other solution out there today that could actually protect a bucket with 70 billion of objects. When it comes to RPO, RTO, the same way. We actually back up faster and also restore faster than anybody. When it comes to RPO, we support up to 15-minute RPO, meaning that you're only behind by 15 minutes in the worst case. The other thing that we should talk about is flexibility. We actually provide multiple modes of backup. Like I said, if it is a data that you care and you have to bring it up very fast, then use what's called the standard tier. But if you have to create a second copy, but you have the luxury to wait, let's say 24, 48 hours, then you leverage something called the archive tier, obviously at a different price point. And then lastly, if you don't have to create a second copy, but all you need to do is actually, fix up the version stack for you to roll back a specific bucket, we have something called the backtrack. This backtrack is also an interesting feature. A lot of the customers that I talk to that uses S3 buckets, they enable what's called object versioning. Once it is enabled, and there's a put that happens on that object, AWS S3, they actually create new versions of that object. So if you were to go back in time, the data is there. It's basically an older version, but it is all present. But then the challenge that we heard from the customers is that if you have a bucket with billions of objects and you want to take that bucket, let's say 5 hours ago, while the data is all present in the bucket, in the form of older versions, there's nothing out there that would actually go fix up all of the version stacks for all of those billions of objects so that you can time travel your bucket back and forth without making second copies. Because in theory, versions are there. You're paying them already. But Backtrack allows you to leverage that version to actually time travel, for example. So that's the modality. We offer multiple ways for you to protect. The second thing is that we offer something called what's called the protection group. Think of the protection group being more of a filter. Like I said, you have a giant bucket. You have things that you care. You have things that you don't care. But maybe you also have things that you have to back it up exactly for 1 year, things that you have to back up exactly for 7 years. But if somebody comes to you and he tells you, you have to make a decision at the bucket level, that's not going to work for you. Because you will have to either back up more than what you have to, or don't back up at all. Or in some cases, you have to, when you have to make a decision of retaining exactly for 7 years, or exactly for 1 year within the same bucket, you're bound to break one of them. But we actually allow you filters. You can actually apply policies at the prefix level with Clumio. You can say, hey, back this up, this /1 year data for 1 year, the /7 year for the 7 year, and then this /junk to not back it up, exclude that. So that's yet another way for you to carve out exactly what you need to back up and back up exactly what you need, nothing more. Yes, flexibility in terms of backup is one thing, but we also allow you different modes of restoration. We do full restoration in the case where the entire bucket is gone, but we allow you to do granular restoration, just restore subset of your buckets. But we also offer what's called instant access. We integrated with what's called the S3 access point. S3 access point acts and behaves just like any S3 endpoint. But when I get API, I sent over, essentially that triggers a Lambda function. There's no data backing it up. But what we do is that we use that trick to actually use that Lambda function, retrieve the data from the backup, and serve it back to the customer. So what that means is that for the customers with 10, 20 billions of objects backed up in Clumio, they can access that data near instantaneously using S3 access point without having to restore the full data, for example. So they do get a read-only copy near instantaneously. So different modes of backup, different modes of restore. Let's talk about DynamoDB. In the case of DynamoDB, again, scale and performance is very, very important. Just because we do have customers with about 900 billion items in a single table. And these are serious big buckets, tables that we're talking about. And then in the case of DynamoDB, we also have to think about the cost efficiency. Back 2 years ago, I think we're the first one that launched incremental backups as air gap copies. Customers came back and they told us that they wanted to actually create discrete copies of their DynamoDB tables for them to protect it. Because AWS DynamoDB pitter is actually attached to the table. It's not a discrete copy. So what they wanted to do is to create discrete copies, like actual backups. The problem that they were facing is that all of the backup solutions out there was doing full backups. So now, if you have to keep 30 recovery points, and you have, let's say, 1 terabyte table, those 30 recovery points means that you have to pay for 30 terabytes, because they're all full. So then what we did is we went ahead and solved that problem by implementing basically incremental forever backups for DynamoDB. All that data, again, is air-gapped in that account that I talked about a few slides ago. So it's truly discrete backup that is air-gapped and is forever incremental. And when it comes to TCO, you're now comparing full backups versus incrementals. After that launch, we actually talked to a bunch of our customers, and then we discovered yet another problem, which is related to the flexibility. And this is one thing that I'm just going to walk you through with some of the diagrams. I'm going to start with the problem statement. That's the customer table. The customer organizes their data through partitions. They will actually store all the data for that customer for the 10 and 0 in partition 0, 10 and 1 in partition 1, so on and so forth. Basically, 10 partitions in DynamoDB table. What's the problem is that this company, they're doing what's called a rolling upgrade. They go ahead and upgrade software for 10 and 0, and then they do it for 10 and 1, and so on and so forth. And then what happens is that right about 2:30, a bug gets reported. So basically, the 10 and 0 got updated at 1:15, 10 and 1 got updated at 2:10, and a bug got reported at 2:30. Saying that the 2 upgrades that we did actually caused the 2 partitions to be corrupted. Your business goal now is to roll back 10 and 0 back to 1:15 and roll back 10 and 1 back to 2:10. These are 2 different partitions. Now the problem was that all of the backup solutions, including Clumio at that time, was allowing them to restore full tables as new tables. Like you have to create a new table, and there's no way for you to actually restore things in place. So then this is what you had to do a couple of years ago. First, you have to do 2 full restores. 1 full restore back at 1:15, and another second full restores at 2:10 p.m. So we just did 2 full restores. After that, what you have to do is take the partition 0 from the first full restores, copy it over to your production table, and take the partition 1 and copy it again to your production table. And only after that, you can go ahead and delete those temporary tables, and then that will be the process of restoring. That's the process of you rolling back the 2 partitions. If you look at the workflow, it's very complicated. You did 2 full restores, you've done 2 copy operations, and you have to delete all of these temporary tables. To think about it, it is slow, costly, and very complicated. Now, with Clumio, Backtrack, what we've done is that we allow 2 things. Let me just kind of play it out because it looks like I'm out of time. So what we implemented is pitter, granular restores, and restore in place. Pitter allows me to pick any point in time at the second granularity. So I pick 115 and 210. Granular restores allows me to restore any arbitrary piece of that thing. I don't have to restore full tables. And then the fact that I can actually do restore in place, I can actually take that data and copy it over to the source table. So what was a very, very complicated workflow now becomes 2 API calls if you're using Clumio. So all that with some of these real world examples, obviously all of this tech has to map into some customer outcome. And these are actually real outcomes from our customers. Then RPOs, bucket with 70 billion of objects, and TCO savings from 15%, sometimes even higher in the case of DynamoDB, depending on your change rate, because you're comparing full and incrementals. Okay, that's my last slide. Before I wrap it up, let me give you a little bit of a teaser. We are working very, very hard to actually be the first one to actually come and launch backup for S3 table. So it's very, very close. I can't tell you the date, but you know I'm going to use my developer trick. I'm a developer. So it's coming very, very fast. That'll be very exciting. And then lastly, we're out there in the booth. So stop by on the booth. Happy to catch up. If you have any questions, just come by. Stop by at the booth. Thank you.